Hello everyone, welcome back. In this video, I want to put together a lot of the topics we've learned related to strings, including string member functions and working with string streams to solve one problem. The problem that we're going to solve is called string tokenizing. Let's head over to the notes and take a look at the problem. We learned in the last video that information in a string can be separated into pieces by spaces, for example. Well, not all pieces of information in a string are separated by spaces. Sometimes they're separated by something else. In this video, we're going to solve the problem of how can we break strings into pieces, also known as tokens, based on any character or any string that's used to separate values or tokens. So let's go ahead and open up a file called stringtokenizingfun.cpp so we can prepare to write some code related to string tokenizing. Let's talk a little bit about some background information related to string tokenizing. Often the information in a string is separated by a special character or a sequence of special characters, aka a string. This special character or special string is called a delimiter, meaning it delimits data. You can think about a delimiter as a separator. Well, we were working in our last video on a problem where we had spaces in between the course prefix, the course number, and the course language. In that case, the space was the delimiter separating tokens or pieces of information in the string. Then we worked with another problem where we had the new line character separating strings into different lines. In that case, the new line character is the delimiter. Another example of a delimiter is a comma. In fact, there's a file extension called CSV that stands for comma separated value. And a CSV file contains data for a spreadsheet program like Excel. In a CSV file, each row is on its own line, and each piece of data in a row is separated by commas. These commas are used in order to separate the values into their own columns when opened up in a spreadsheet program. So here we have two delimiters. The new line character is used to delimit rows, and the comma is used to delimit columns. So here's an example. Let's say we have a student ID number, such as 1000, separated from the first name, such as Jane, by a comma. Then we have the last name separated from the first name by a comma, the class standing separated from the last name by a comma, and 3.5, the GPA, separated from the class standing by a comma. So this might be a row of information for a student in a CSV file full of information about students. I have an example of a CSV file that I've used before in my research. This is what it looks like here. Though it looks a little intimidating at first, if you were to open this CSV file up in a spreadsheet program instead of as plain text, you would see it looks like this, which isn't so intimidating to look at. The first row of a CSV file is usually called the header, and the header has information about the names of the columns. For example, this column here stores information about calories burned, distance traveled, elevation, floors, heart rate, steps, sleep level, etc. This data is information that I've downloaded via the Fitbit application programming interface, or the API. And this represents real-world, minute-by-minute Fitbit data. The first column, though it's unlabeled, represents the timestamp. For example, midnight, 12:01, 12:02, etc. Seeing the data in this form, it makes a lot of sense, right? Each row represents information for a minute of data, and each column represents a measurement at a particular timestamp. But looking at it this way, it looks a little bit more challenging to interpret. Well, we can process this CSV file using our knowledge of string streams and strings in C++. For example, we can read in the first line outside of a loop, then read in the rest of the lines inside of a loop until we reach the end of the file. For each line, we can use a istringstream in order to process each one of these tokens separated by a comma in a row. And that's what we're going to do today. We're not going to use this file, though we could. We'll instead use our own file that we'll make up inside of the VM. So let's go ahead and do that now before we move on. Go ahead and open up another file, and let's call it studentinfo.csv in gedit. So this is going to be a comma separated value file, which is a very common file. You saw one example of it for Fitbit. Now let's make another example here using student information. So let's first specify the header, which would be the first row of our spreadsheet. Let's say we have an ID number, and then we have a first name, then we have a last name, then we have a class standing, then we have a GPA. Now go ahead and add at least, I'd say, 3 rows, one for each of 3 students, representing some dummy data to fill in for these columns. Awesome. We now have a CSV file of our own that has 3 records of information for students, and it's got a nice header that describes what each piece of information represents. Now let's say we want to read this information in via string tokenizing fun. How would you write code in order to read each piece of this information in from a file? Well, first we would have to include the fstream library. And then we would have an ifstream variable called input file, which we would open to be our studentinfo.csv file. We should check to make sure that this successfully opened, but for the sake of time in this video, we'll just move on and assume it opens correctly. Now, once the file is open, we're going to want to read in line by line the information in input file. However, we want to read the header line in first. So let's go ahead and do that. Let's declare a string called header and a string called line. Let's first read in the header, and then we'll read in the line, and we'll read in each line inside of a loop. Looks like we are successfully able to get the header file. Now time for the loop. Awesome, it looks like we're able to get each row of our data. We've got an extra new line character being printed here. This new line character is coming from the new line character hanging out at the end of our header. So we might need to use a getLine again to get rid of it, or I'm actually going to convert this to use getLine just to make things a little bit easier. And that'll fix our problem. Now that we've read in each row into the variable line, we want to extract each piece or each token of information from line. For example, we want to grab out the ID number, the first name, the last name, the class standing, and the GPA. If these were separated by spaces, we would know exactly how to do that. In fact, we've done something very similar working with student information when we first started working with files. So how do we do this now that our delimiter is not a space and it's not a new line? Well, getLine by default uses the new line character as a delimiter. But getLine is overloaded such that we can pass in a third argument specifying what character to use instead of new line as a delimiter. This is actually really cool. This means that with getLine, we can get lines from any string, any stream, any file we want, where we get to define what is a line. A line is all the text between the delimiter that we pass in as the third argument. So let's do that now. Here, in this if statement, we know that we successfully read in a row. So now we'll use getLine and istringstream in order to tokenize the pieces of information separated by commas. So in order to do this, we'll need to declare an istringstream. Since we're going to be using the istringstream inside of a loop, we'll need to set the string to be line each iteration, and we'll also want to clear out any state from the previous iteration. So let's do input string stream dot clear and input string stream dot stir and set the string to read from to be line. Now we've got a new little subproblem. How can we walk through each line, which we want to separate by commas, in our input string stream and extract out each piece of information? Well, we'll need a place to store each piece of information. So let's go ahead and add a string for the ID number, for the first name, for the last name, and for the standing. We'll also need to add one for the GPA. Even though the GPA is a double value, we could set this to be a double value and then use the stream extraction operator because it's at the end of the line. But if this was mixed in here, we wouldn't be able to do that. So that's why I want to solve this as a string, and then I'll show you how to convert a string to a double later. So let's go ahead and start grabbing some information. Input string stream. We will extract first the ID number, and our delimiter is a comma. Then we'll extract our first name, and then our last name, our class standing, and then last but certainly not least, our GPA. We should check to make sure that each one of these operations were successful before we use the value. But for the sake of time, let's just go ahead and see out all this information. All right, so all the lines that start with red, that's where we are printing out the whole line as a single string. And then after that, we're printing out each piece of information separated by a space. So it looks like we are successfully able to extract each piece of information by tokenizing the string using the comma delimiter. So that's awesome. The last thing that I want to show you here is how we can convert a string into a double. Like, for example, GPA. Since we're using getLine, we have to specify a string here, but GPA is a numeric value and it should be stored as such. If you head over to the notes for this lesson, you'll also, before we move on to converting strings to and from numeric types, you'll also see a few more examples of string tokenizing. For example, if you have a string that's separated by stars, then you could use this code here in order to use the star as a delimiter with getLine. So here are just a few more examples, and more reading for string tokenizing can be found in Gaddis 10.7. Okay, converting strings to and from numeric types. So if we need to convert a string to a double, we can use stod for string to double, which is in the string library. So you'll have to include the string library in order to use this. If you need to convert a string to an integer, you can use stoi. If you need to go the other way around, you have a numeric type and you need to convert it into a numeric type, into a string type, you can use the toString function also in the string library to do so. And here's an example of doing that. Okay, so let's apply stod in order to convert our string GPA into a double GPA. So let's declare a double, call it GPA double. And right after we read in the GPA as a string, let's assign to GPA double stod passing in GPA. And then instead of using the string GPA, let's use the double GPA double. And I'll make a comment here, string to double. We'll need to include the string library in order to use this function. Looks like we get the same output, but we know that this GPA value coming from GPA double is now a numeric type. So if we wanted to write some code to, say, compute the average GPA, we could do so now since our GPAs are numeric types, whereas before they were strings and we wouldn't be able to do that. So to wrap up, string tokenizing is a really great application of what we learned about with strings. We can use istringstream in order to read from a string with getLine, where we can specify a third argument saying, hey getLine, here's how we're classifying lines in this string, using commas or using stars or just using something other than new line characters.